Welcome to edgeofcode.com's series of infinite roller tutorials. If you prefer a written tutorial, you can go to the website. It's under tutorials in Unity. In the previous tutorial, I showed you how to create images in Inkscape, how to import them into Unity, and how to add physics to the objects. Today I'm going to explain what prefabs are and how to use them, and we're going to write some simple scripts to generate some terrain. So first of all, open your project, and if you can't see the scene that we created last time, go to your scenes folder and double click on the scene that we saved, and this should load up. Go back to assets, right click, create and folder, and create one called Prefabs. So a prefab is basically a template game object. So it is a game object, but it's one that you can reuse again and again. So we want the ground to be a prefab, and all you need to do to create a prefab from the ground is drag it into the assets folder, well, into the prefab folder for us. And that's now a prefab, and you can tell because this is now turned blue that this is a prefab in the scene. Also, it says prefab here. So some of the things that are useful for prefabs are if you change, so I've clicked on the prefab, if I change the prefab in the inspector, then it automatically changes all of the prefabs in the scene. Get rid of that. But if I do it the other way around, if I change the piece of ground, the prefab doesn't change, so it's still a trigger. I'll take that off now because we don't want it to be. So delete the piece of ground in the scene because we're going to create all of the ground programmatically. And next, create a new folder called scripts. And inside that, right click, go to create, and create a new CSharp script called chunk. Taking a moment. Open the script. Interesting. Hopefully it won't take too long. Okay, so monodevelop is the IDE that Unity uses. A class is kind of like a container for some code that does something specific. So this code is going to describe a chunk, and let's see, I'll show you how this is going to work, and so what a chunk is. So if I draw our character, there we go, and some ground. Let's say 3 pieces of ground, and I copy all of those, can make some more over here and some more over here. So a chunk is going to be some number of pieces of ground. So each of these 3, for this case, is a chunk. This one is a previous chunk. This one is called current chunk. And this one is called next chunk. The character rolls across these pieces of ground, and as it goes, we will remove the previous chunk and recreate more ground, well, create more ground ahead, so that then the names get renamed. So this is the previous, this is current, and this is next. as it rolls further, we then get rid of this chunk and move it over here, etc, etc, etc. So this class called chunk is going to describe one of these groups of ground. So this colon mono behavior means that chunk is a subclass of another class called mono behavior. Mono behavior is one of Unity's own classes, and any script that is going to be attached to a game object, which this one is, should be a subclass of mono behavior. It automatically will be. There are other things that this could be a subclass of, but we won't go into that at the moment. I'm going to delete all the things in there. Okay, so first we'll create a new public variable to represent the prefab that we made of the ground. So type in public game object, and MonoDevelop will automatically come up with suggestions of what it thinks that you're trying to type. So you can just press enter when it's guessed the right thing. So public game object ground prefab, ended with a semicolon. So ground prefab is the name of the variable. So when we want to refer to the ground prefab in the code, we use ground prefab. Game object is the type of object that ground prefab is, and game object is what we've been talking about in the scene. So the character is a game object. So if I were to refer to the character in the code, it would be a type of game object. Public is called an access modifier. Public means that this ground prefab can be accessed by other classes, and in Unity, if I save this by doing Control S and go back to Unity, if I right click in there, create empty, click on that and rename it chunk, and then drag the script onto that to add it as a component, you can see that we have a ground prefab slot here. So in Unity, when we have a public object, it doesn't have to be a game object. We then come back and we can assign it some value in the inspector. So we want to assign it the ground prefab. So go to your prefabs folder, click and drag ground into the slot. And now anytime that we use ground prefab in the code, we're actually referring to this object. And you need a semicolon at the end of every line of code, because it tells the compiler that you finished with that instruction. Okay, so next we're going to create a method. So type in void awake. Awake is one of Unity's own methods. So when we write the code in awake, what we're doing is telling Unity to run that code when we press play. So it's when Unity loads the script. To see this happen, let's try typing print, which will print what we type in. Awake. And a semicolon on the end. These quotation marks here make the thing inside a string, which is a set of characters. So Control S to save it. And if I then click on console down here and press play, we see that it says awake when it loads up. So to explain a bit more about methods and what they actually do, after the awake method, type in private void print to screen string words. And print words. Okay, so this method is private. that means it can only be accessed from within this class. It has a return type of void. A return type tells you what the method is going to give back to you when you call it. So void means that it's not going to give us anything back. Print script is the name of the method, and it's what we use to call the method. And by call, I mean this. So we're gonna write awake with lots of exclamation marks. So this is calling the method. I'm passing through a parameter called awake, or a variable called awake, which is a string. The parameter is called words, and we're printing what's in words, what's in the variable words. If I play this now, the same thing that happened before will happen, except this time, oh, sorry, I didn't save it. You have to save it, otherwise it will try to play your previously saved version of the script. So if it doesn't do what you expect it to do, see if that has happened. So now I do it, it's got awake with lots of exclamation marks at the end of it. Okay, so we could also create a new variable called awake words and assign it a value of I am awake. Semicolon. And pass through that variable. And then this would print out I am awake. There we go. So, okay, let's delete this now, because that was just to show you how they work a little bit. And create a new public method called initialize chunk. I'm also going to add a comment at the top to tell us exactly what this is going to do. So a comment is something that's just for us. It's ignored by the compiler, and it's just to give us more information about what we're doing, so that if we come back to it a long time in the future, we don't have to go through all the code and try and figure out exactly what's going on. We can just read the comment and think, ah, cool. So this method is going to initialize the pieces of ground that make up the chunk. Okay, so first we're gonna just make the chunks like this. We're gonna build it in a straight line, so it won't be very exciting, but it's something we're going to build on in later tutorials and make it much more interesting. So first, to do that, we need to know the number of pieces in a chunk. So we're going to create a variable to do that. I'm going to call it, this is going to be a constant variable. That's why we had this word here, const. It means we can't change it. It's going to be an int, which means that it's an integer or a whole number. And I'm going to call it chunk size. Give it a value of 30. So chunk size is in capitals because that's how we refer to a const type variable. It's a convention, not a rule, and it's just so that if we then use it later in the code, we can see automatically that it's a constant value and we can't change it. I'm also going to add a different sort of comment at the top, which is 2 forward slashes. We tend to use this / star sort of brackets for comments that are above methods, and forward slashes for other types of comment. So I'm just going to write that this is the number of pieces in a chunk. Well, number of round pieces in a chunk. We're also going to need to know the width of the ground prefab, and for this I'm going to create something called a property. So it's a float, which is a numerical value, but rather than being a whole number or integer, it's going to be a decimal, and it's going to be called width ground prefab. So actually, it's going to be private. So a property is a bit like a simple and specific method that's used like a variable. So the property is shorthand for having something that a specific method that gets a variable and a specific method that sets a variable. So we could actually write this out longhand. We could have a private variable called width, and then let's copy this, a public way to get them or set them. So private means that we can't actually set it from another class. Can only set it from within this one. The get in here is shorthand for returning the value of width. And if we assume for a moment that it wasn't private, set would be shorthand for just giving width a specific value that we would, so we do width ground prefab equals something, and that would set it as that value. This is shorthand for all of this. Okay, and save that. So all that means is that C# actually auto-implements all of that other stuff. So it auto-implements a private class variable and generates the get and the set for it. Okay, so now we actually want to set this. So I'm going to write a comment to say that we're going to set the width of the image. And the way to do that is to access some of the information in the ground prefab. So the ground prefab has a sprite renderer, and that sprite renderer has information about the size of the image. So first we want to get a reference to the sprite renderer. We call it rend. And to do that, we refer to ground prefab and then do a dot. The dot then gives you all of the variables and methods that we can access. So for this one, we want to get component. Get component gets a component from the prefab. The component type we want to get is a sprite renderer. So we just do that, a semicolon on the end. We could also get the collider. To get the transform is slightly different. So for the transform, it would be ground prefab dot transform. So the transform, we don't need to use get components because it's a variable rather than needing a method to get to it. Okay. So now to get the actual width, we do rend dot to access its variables and methods, bounds dot size dot x. So bounds is a class that describes the bound of the image. Size is a variable in the bounds class. It's a vector 3, which is a type of variable that has an x, y, and a z component. X tells us the width in this case, y would tell us the height, and z would tell us the depth. So this whole thing gives us the width of that image. So get component is a method that's available to all game objects. Okay, go back to Unity, and in the scripts folder, right click and create another new CSharp Script, and this one called terrain generator, and open it. So this one is actually going to generate our terrain using the chunks that we create. So this one is going to have 3 chunks, because we're going to have 3 chunks at a time. We're going to have a previous one, a current one, and a next one. So we're going to have public variables because we're going to want to assign them in the inspector. It's going to be of type chunk because we want to access the chunk script rather than the game object itself. And one's going to be called previous chunk. Let's copy and paste that. This one's going to be current and next. Save that, Control S, and then go back to Unity. Create another new empty game object called terrain gen. Drag the script onto it, and then you can see that we've got 3 empty bits. I'm going to assign them now. So at the moment we've just got 1 chunk. We want to duplicate that game object 2 more times. So make sure you've clicked on chunk and then do Control D twice, and that duplicates it. Now rename each of them. So this one's going to be previous. To rename them, I just click on it and then click again, and then you can type in okay, and then I'm gonna put them in order to make it less confusing. So terrain gen, I'm gonna drag previous chunk onto previous chunk, current onto current, and next onto next. So yeah, now whenever we use these in the script, we'll actually be using the previous chunk's version of chunk script, or current chunk's version of chunk script. Okay, so now go back to the chunk script, and we're going to create another new method. This one's going to be called reposition chunk, and it's exactly what it sounds like. We're just going to use it to change the position of a chunk. So we want to do this because we want to be able to move it across. So reposition chunk. We're going to want to pass through a new position. Positions are stored in vector 3s because they have an X component, a Y component, and a Z component. And to assign a new position, we need access to the transform. So this is the transform of the chunk game object that this script is attached to. Dot and position. And to reassign, we just use equals and new position. Semicolon at the end, and Control S to save. So go back to the terrain generator script now, and create a new method called start. Start is another of Unity's own methods. It's called after all of the awake methods in all of the scripts have run. I've used the start method in this one because I want the chunk code, or the awake method in chunk, to run before this code does. There are other ways to do this. You can actually tell Unity which order to run the scripts in, but this is fine for what we're doing. So inside start, we want to get the width that we assigned in the other class. So we want to have access to this variable. Get width of round prefab. I'm going to use the previous chunks version. it's going to be the same in all 3 chunks, so I'm just going to use one of them to get a reference to this. Yeah. And then I'm going to reposition each of the chunks so that they're in a good starting position. So we want previous chunk to start over here, current chunk to start here, and next chunk to start here. So to do that, I use previous chunk dot to access the variables in my script. So these ones that we haven't written, they belong to monobehavior. That's what subclass means. It means that I have access to things within monobehavior as well. But for us, we want to access the script we wrote, which is reposition chunk. And we want to pass in a new vector 3. So type in new vector 3. And inside that, we're going to write an X position, Y position, and a Z position. The X position is going to be minus width prefab times the number of chunks. So we want, in this case, it would be 3 times whatever this distance is. And in our code, that's width prefab times this value of chunk size, because that's the number of pieces in the chunk. To access that, it's chunk size. You might notice that this is a different way of accessing chunk size, and that's because chunk size is a constant variable. As well as being a constant that can't be changed, it means that it's a static variable, which means that it's a variable that belongs to the class itself and not to an instance of the class, which the other variables that we've created do. So when we have previous chunk dot reposition chunk, we're calling previous chunk's reposition chunk method. When we have current chunk dot reposition chunk, we're calling current chunk's reposition chunk method, etc. Okay, so let's continue with this. So that's the X position. The Y position we want 0 because we don't want to move it at the moment, and same for the Z. For current chunk, we're going to position it at 0. So a short way to write that is like this. Vector 3 has an inbuilt 0 variable built in. And for the next chunk, instead of minus width prefab, it's going to be plus, because we're moving past the current chunk to start here, which is going to be the width of chunk size number of prefabs. And the X and the Y and Z are going to be 0 again, because we're just making a straight line for the moment. Okay, so save that, Control S, and then go back to the chunk script. And inside initialize chunk, we're gonna now create the pieces of ground. So we're gonna write a for loop, which is written like this. I'm just going to type it and then I'll explain this all in a sec. Oops. Okay, so this line is a for loop. The int I equals 0 means an integer variable I starts with a value of 0. The I++ is shorthand for I equals I plus 1 and means that on every loop I is incremented by 1. So the loop is between these two brackets. The I is less than chunk size means that it loops until I equals chunk size minus 1. So it never reaches chunk size because it's less than it. The code inside at the moment instantiates or creates a new game object. So this creates a new piece of ground every time the loop runs. Okay, so let's build on this a bit. So we're going to set a parent for our ground piece by doing ground piece dot transform dot parent. Okay, and then we're going to set it as, not trunk, as the transform of the trunk, which is just transform, and then with a semicolon. So parenting in Unity means that if we move the parent, the child, which will be the ground pieces, will also move with it. We want to be able to move each chunk with its pieces of ground. So next we're going to add code to position the ground piece object. So I'm going to write out a piece position, and it's going to be a new vector 3. And the x position is going to be the chunk's x position plus I times width ground prefab. The y one is going to be transform dot position dot y, and transform dot position dot z, and semicolon. So the I here is the thing that we're looping over. So the first time through the loop it's 0, which means that the x position is the same as the parent chunk's position. The next time through the loop I is 1, so the position is the parent chunk's position plus 1 width of the prefab. And this will carry on. So this is where a chunk is. We're adding 1 width of the prefab, 2 widths, 3 widths, etc. for however many times we go through the loop. And then we want to assign it to the ground piece's actual position. Piece position. And we also need to call it. Then make sure both scripts are saved and go back to Unity. And now when we press play, hopefully we should see lots of ground generated. And zooming out, we can see all of it. If we click on each of the chunk game objects, we can see which bit belongs to which chunk. And if we look at the child objects for each parent chunk, we can also see each one in the scene view. Okay, so we also need to save the scene and the project, just to make sure. Okay, in this tutorial we've started coding the terrain, and in the next one we'll add code to make the terrain infinite, and we'll also start making a character controller. Remember that you can download the files for this tutorial if you want to on the downloads page at edgeofcode.com, and I'll see you next time.